My name's Grace. I'm a cloud solutions architect based out of the London office, if you were wondering where my weird accent came from. And I'm here to talk to you about designing and implementing disaster recovery systems in GCP, no matter where your production is. So be that on GCP itself, on premises, or in another cloud. So when it comes to DR, there tends to be a number of three-letter acronyms or TLAs. So I just want to start to kind of go through some of those. And I will like to start by actually distinguishing between disaster recovery and high availability. Think about high availability as being for a micro-disaster. A single web server dies in a farm of web servers, or a single disk in a SAN. Think of disaster recovery being when you actually have to fail over to a recovery site because you're no longer able to serve your production environment out of your production environment. So they're orthogonal, but they are related. HA will actually drive what your DR scenario will look like, particularly if you're running your production on GCP. RTO and RPO. These are obviously the three-letter acronyms that everybody knows and will understand when it comes to DR. Think of RTO being the recovery time objective being how long will it take you to get your application back up and running again? Okay. Recovery point objective. Think about that as like how much data are you actually willing or able to actually lose? Think about going back to that last backup you took, or the backup and the transaction log files. Okay. So the smaller the RTO and RPO value, it has an asymptotic impact on your bottom line, i.e. it's likely to cost more because you're going to have to build in more resilience into your environment. SLA and SLOs, okay. They're often conflated, but they are two separate things. The SLO is the measurable component, okay. So here, the measurable component is how many bowls of cat food has this cat got, and obviously how often I give them the cat food. And SLA is the agreement. The SLOs feed into that SLA, and also the RTO and RPO values feed into the SLOs. Now, obviously, I'm not a great contract negotiator because this is going to be one really fat cat. Okay. Okay. So moving on. So I just want to kind of get you thinking about DR patterns before we move on and start actually looking at some of the features that we can help you. So, and I'm going to draw an analogy with having a journey and having a flat tire. Okay, so if you're driving along and you have a flat tire, you have no spare, you come to a complete halt. You have to phone somebody up. You have to get them to come out to you. They have to replace the tire. Okay, that's a pretty cold pattern because you're not that ready for that scenario. However, if you've got spare, yes, you need to halt, but you've got everything you need to actually recover and continue on your journey. You change the tire yourself. You don't need to wait for anybody else. Then you can carry on. And at the other end, the hot pattern would be the fact if you were running run flat tires. Run flat tires means if it has a puncture, you can still continue moving. Maybe a bit slower. And obviously, when you get to the other end of your journey, you'll change it to a proper tire. But you're ready. Doesn't stop you. It just makes you slow down a bit. Okay, so talked about patterns, talked about the TLAs. You need to do some planning. Okay, so you need to start by defining your recovery goals. To think about this, think about your actual application, because your application will actually define what those recovery goals are. So here we've got 3 different examples of different types of applications. Batch processing, that doesn't tend to be time critical. So you can do things, and this is a data proc one, you can do things like take advantage of preemptible VMs. Preemptible VMs are like standard VMs, but you can get them at a lot lower cost. But we will reclaim them up to 24 hours. So with this sort of the batch processing architecture, you can have a mix of standard and preemptibles. So if the preemptible gets reclaimed, if you're using checkpoints, you can either continue processing that little bit of workload from that point, or you can start again, it depends. But the point is, it's the fact that it's kind of a warmish pattern because you can still carry on, it slows you down, you can carry on. E-commerce has different RTO and RPO values throughout the application. So the actual user journey, that's hot. It needs to be available all the time. It's too easy. Users today have a very short attention span, and they will move on. Okay, but the email that notifies them that they've bought something, that's not that important because they know they've bought it. Yes, they'll be expecting an email at some point, but not immediately. It's decoupled. It's fine. And the recommendation engine, that could actually be out of date by a couple of days. Yeah, it's not great, but it's not critical to the journey. And then the other extreme, the encoding and delivery, everything's hot. You need to have resilience everywhere because people want to watch their films. The encoding's got to happen for the platform. So you can see that how looking at your application will define your recovery goals. So you identify the DR patterns that are applicable. You need to design for end-to-end recovery, i.e. not just backing up, but you need to actually be able to go back to your production environment when it's up and running. Okay? Make your task specific. Saying run the recovery scenario isn't good enough. You need to actually provide instructions because you don't know who's going to be there to do the recovery. It might be somebody who's not that familiar. Say, log onto the server, change directory to the DR folder, and then run the file helpmeplease.sh with the command to do that. Implement control measures, okay? You don't really want a disaster. So, if you're taking advantage of the self-healing features within the platform, especially if your production's on GCP, think HA if you can. Support. Make sure your communication lines are sorted out. Make sure you know who to contact in GCP. Make sure you've got your contact details are up to date. And make sure internally that the contact lines are sorted out. Verify your software licensing. Sometimes you're not able to run your software that you're running in production in a warm standby mode. You need to double check those licenses. So if you're using third-party packages, really make sure that you're running it in the correct way that it's allowed to. What happens if you can't connect to GCP? Okay, if your production environment's down, how are you going to deploy if you're deploying from production to your DR scenario? Implement maybe more than one data recovery path. Okay? Think about different ways of communicating how you're going to connect to GCP in the event of a disaster. Test your plan regularly. Okay? You can use things like Deployment Manager to bring up your environment and bring it down. It's something that makes DR in the cloud so much more compelling because it's just so much easier to do this. Security in your DR plan. Okay, you need to maintain permission consistency between your on-prem and GCP, okay? You've set up controls on-prem or in another cloud, and you need to mirror that when you fail over. The permissions you put in place shouldn't be forgotten about. Make sure your users can log into the DR environment. Don't expect them to be able to log into the DR environment for the first time when you have a disaster. Practice. Get them to understand what they need to do. Train them to use the DR environment. Things will be different, particularly if it's on-prem and going to GCP. If it's within GCP and they're used to that, then obviously it's not a big deal. But if they're used to logging on to their on-prem stuff, you need to think about how you get them to log on elsewhere. Mirror your security controls in GCP, okay? So if you classify your data and you've got particular controls around that, mirror that in GCP, okay? So you need to understand how to map your security controls to using the things like IAM in GCP. And manage your secrets properly. Configuration files. If you're running the downloaded service account keys, manage those properly as well. Use encryption, things like that. Okay. So now I'm going to just go through and start talking to you about the DR building blocks. And these are features of the platform that lend themselves to DR and HA. Okay. Stack driver. It's often the first sign of a problem is with your monitors and logs. So Stack driver works across AWS and GCP. Uptime monitors, alerts, login, and error reporting. I'll come back to cloud storage. We'll dig into that a bit easier. But it's an object store for things like backups, data files. Cloud DNS, it allows you to programmatically change DNS values. So in the event of a failover, you can get it to automatically, with an automated failover script, change the records to point elsewhere. So cloud storage has a number of storage classes. Nearline and cold line are particularly suited for DR scenarios. Okay. Cloud load balancing. So a very common pattern is to have a single IP address that fronts either a single serving instance or multiple instances. So cloud load balancing gives you a single anycast IP address. It tends to be integrated with managed instance groups. Managed instance groups allow you to scale up and down identically configured instances. And so that, therefore, it's only a single IP address, or you can have it so it only runs up a single serving application. You can have it set so it only serves one instance at a time. And if that instance has a problem, replace it, but it has exactly the same IP address. Okay. So compute engine, again, as you'd expect, I'll come back to that because it is the workhorse. That and cloud storage tends to be the workhorse for DR. Kubernetes engine, which is our managed Kubernetes service. And you've probably heard a lot about Kubernetes over this event, so I'm not going to say too much. But basically, it allows you to have the same workload on multiple platforms. Cloud Deployment Manager is it's a key feature. This allows you to create repeatable and consistent environments. So you can define your recovery environment, you can and deployment manager, and when there's a disaster, you can bring it up. Also, when you want to test, you can bring it up and bring down, because you only pay for what you use. So test, test, test. So let's have a look at some of the components of Compute Engine. So when you start up an instance, you start from what's called an image. So this image can be fully baked. So where it's got everything on, it has less external dependencies. So maybe for your web servers, that's a good example. They have fast boot times. The trade-off is that that is your version control. So therefore, you're going to have to manage more of those images. At the other end, you can have, start off from one of the public images or your public image, and then you layer everything on top. So there's more dependencies. It has a slower boot time. And then there's the middle ground where you may have all your applications done, and then you only actually do load up the updated files as and when needed. Depending on what that instance is doing, depends on which of those you will choose. So a database probably doesn't need to be fully baked. You probably set it up, and then you just do upgrades. Persistent disks. So persistent disks are block storage that are attached to instances. Two types, standard and regional. So standard zonal, so it will exist in one zone. Regional, it uses twice as much storage because there's synchronous replication across two zones in a region. Okay. You need to set the permissions. You need to grant the permissions to attach disks to instances. You can set the auto-delete flag on a disk to false. Sorry. So that means it won't, when the instance is destroyed, that disk will continue to live on. So you can attach another instance to that disk that's there. And also, don't forget to mount the disk from within the instance. So at this point, because you're probably fed up of hearing me talk for so long, I'm now going to invite up Chris from Cloud Endure, who's hopefully going to give you a demo of how they can actually help you with your DR scenario. Thanks, Chris.
Get those up. But essentially, Cloud Endure was founded in 2012. Is it on here, Grace? Watch PowerPoint.
Click us there.
Oh, beautiful. 2012, out of Tel Aviv, by four Israelis who were essentially entrepreneurs, serial entrepreneurs. Since then, we've grown to 4 different offices, 3 here in North America, Boston, New York, and Los Angeles. We started with $18 million in funding. That was just our first and only round of funding by strategic investors and obviously notable venture capital firms. As you can see, some of these investors actually have disaster recovery or backup products built in, so it's interesting to note those. I'm not big on logo dropping, obviously, but it is nice to look at the ecosystem of our customers and channel partners, the diversity of it, the size, and obviously the different verticals. I think that what this speaks to is our flexibility in terms of working with organizations of different sizes and scopes and focuses. We also paid close attention to our channel partners to make sure that they have all the tools available to them to deliver a valuable product to their customers. So Cloud Endure essentially is a three-legged monster in terms of solution use cases. However, the underlying technology is identical. It's exactly the same, with just a couple different variations in terms of workflow or executions. From a diversity standpoint with cloud, we want to make sure that we're selling diversity and redundancy, that we have a diverse group of different cloud providers kind of in our arsenal. So we work obviously closely with GCP and the other public cloud providers out there so that we allow diversity across clouds and within clouds. So how does it work? The technology from a very granular fundamental standpoint, these steps are what we're going to ask you to do and what the executions are on our customer's end, which is install an agent initially. It's an OS-based, very lightweight kernel agent that we install on each machine, whether it be virtual, physical, in the cloud, or on-prem. What that agent's going to do is connect with our management console, where within the console you're able to configure a blueprint, which essentially defines the resources within GCP that are required to then spin up those target instances and make them available for production. As Grace was saying, test, test, test. One big value prop for Cloud Endure is our ability to test at any frequency that our customers would like. They can do it on a Friday afternoon before happy hour. They can do it weekly, monthly, biannually. I know that's part of most DR planning, so it's important to understand that you can test by the click of a button whenever's required. And then once the testing is completed, we want to do it at the very beginning of implementation, and then obviously always and often, but at that point we're able to fail over and we have those workloads available no matter what in GCP come time for a failure or to run these drills. So here's kind of a high-level overview of the architecture, and I think what's important to note is on the left side what you're going to see is your source infrastructure. So whether that be an on-prem data center, whether that be a GCP production environment in East or West or Central. So you have obviously your machines working here. We're going to deploy these agents on any Windows or Linux workload or machine with all of the volumes attached to it. It's going to identify itself up to our management console that you see up top there. And what that console is going to have is obviously the blueprint piece, but all it really takes is metadata, so the size and quantity of those disks. What we're then going to do with that through that management console is Cloud Endure is going to manage and orchestrate our staging area, the middle piece. And essentially all that is low cost, low compute resources. I believe it's an N1 small or N1 standard that we provision for the replication servers, and those servers are just recipients for the agent traffic that then have, I believe, 15-to-1 ratio from replication server to volumes attached, and that's where your data is going to sit. So at this point, you can kind of ignore the far right target network because this is kind of business as usual in terms of our disaster recovery. You're going to see a total cost of ownership reduction of typically about 80% versus legacy DR architectures. So then when we actually need to run a test or when we need to fail over in the case of a disaster, Cloud Endure is going to automatically orchestrate all the necessary resources and spin up that target environment in production with sub-second RPOs and RTO of minutes. When you're done, we fail back, we just switch the architecture around, source becomes target, target becomes source. You can fail back whether it be deltas or full bare metal, and then we just turn down that second instance so you don't have to essentially pay for it on an ongoing basis. Okay, pop into here, into the demo. So what you see here essentially is the management console. It's very simplistic. A lot of Cloud Endure, a lot of our approach has always been simplicity. So to kind of dig into this, for the sake of time, we have this list of machines, an application server on the front end that essentially is running a WordPress blog and a MySQL database on the back end. You see here on the replication process, this is the stage that it's in, so it's in CDP mode. So you're having a real-time copy residing in that low-cost staging area. Let me dig into this a little bit. So, and this is essentially that metadata I was talking about. This is the only data that Cloud Endure is ever going to take or look at or have access to. We don't ever look at the data, have access to the data within those workloads. So let's go ahead and pop over here to our WordPress. This is not the WordPress. Okay. This could be interesting. This is the site, but not the press. So let me figure out how to pull this up. Essentially, what we'll do is we'll see it in job progress. And I want to make sure we don't run over time here. But this is our WordPress that we would be typically updating. So I would put on there whatever time it is, 4:56 p.m. And then I would go into here, select these two instances, and launch these machines. You have two options, test and recovery. The only difference here is that with recovery, it's essentially going to prepare those instances for a fail-back scenario as well. So we're going to run this test. Just going to make sure I want to do it. Here you have all your RPOs. So these are the different recovery points that you have available to you. So essentially it's every 10 minutes for an hour, every hour for a day, every day for a month. And our new release will be having customizable RPOs as well, recovery points. Continue a test. So you see up top here, these machines have been launched, and the job progress will provide more details. So while we're waiting for these to launch, we'll kind of take a look at this progress, the job that started, and we're waiting for the latest snapshot. So right now, what that's doing is provisioning all those resources within that GCP environment. It's orchestrating all the necessary production resources, and converting, with our automated machine conversion, converting any unlike source infrastructure into something that's workable in GCP. So if you have an on-prem environment that's a little bit legacy, like a server 2008 or something, and we need to convert some of those hypervisors or workloads into something different within the cloud, within GCP, then they'll convert that for you all automatically on the back end. So let's drill down into these machines one more time and show you a little bit about the blueprint that I was speaking of. So within these blueprints, this is where we are defining essentially those resources that are required. It's just machine name, quantity, size of the disk, essentially, what we want to run those on. So right here we have an N1 standard, but obviously there's different variations depending on the complexities, the size, and different variations of your source workload. You can customize the name of these servers, so different projects or different SQL databases might be 10, 15, 5,000 that you're managing. So in here you can customize those. We define a subnet, so essentially is a private network for the exclusive use of Cloud Endure in this DR or this replication process. Private IP and elastic and public IPs as well. The disks required. On the network side, you have the ability to throttle bandwidth. So during the initial sync, obviously is when we're going to utilize those resources the most. But after that, if we wanted to just make sure that production's never interrupted from a bandwidth perspective, you can throttle this up and down depending on needs, but typically the default is just fine. The dashboard essentially is a high-level overview of the licenses you have allocated to your pool of licenses, what's in initial sync mode, so that initial seeding of the data into the low-cost staging area, and what's ready, which means it's in full CDP mode and you have a real-time copy just waiting for failover, waiting for that execution to take place. Typically, between these two phases, it pops into the require attention. So after the initial sync, it'll say require attention, which just means we highly recommend that you do some testing on this. Again, we're always going to promote test as well. The audit log essentially is an overview of all the different transactions that have taken place. You've seen that we've run the demo a few times in the last couple days. It also shows test launched. You can delete the replication. So all this is kind of taking place on the back end, giving you a bit of an audit trail for compliance reasons or for internal best practices. On the setup and info, you have the machines associated with this project, your GCP credentials. These credentials, again, go back to that kind of just defining where we're going and what we're doing with it. Replication settings in terms of what your source is and what your target is. So in this case, we have, I believe it's AWS as our demo environment to Google Central. The replication servers, host names, et cetera. So everything that's sitting on that source from the OS level, from the disk level, is being replicated fully. Every setting, every security group, subnets, disk sizes, all of it is completely just again, in real time, and block level replication taking place, ready to be restored based on that blueprint definition. And some of these are just other settings that can go into email notifications and whatnot. So to add a new machine, we go up here to how to add new machines. And it's as simple as deploying an agent. That agent immediately syncs with the GCP cloud environment that you've defined and goes into sync mode without any further action required. Let's get back to the machines. And you'll always, again, see which phase they're in here. When they were tested, it looks like we actually launched our SQL so far, and our target machines have been launched. So you can see that in here we have an RTO of 7:56 p.m. to 8:01, so about 4 minutes. And we have fully functional, what would be a WordPress with an update to it, executed and in failover mode. So from here, again, until your source machines are back up and running, we can fail back at any given time by flipping that architecture. And then the best part about it is we select these machines. And we delete these target instances, saving us all the money associated with GCP resources being consumed. Thank you. Thank you.
Gods were mostly with us. Okay, so continuing on. So yeah, okay, we're going to be tight for time. Okay, so first thing that you need to think about when connecting to GCP is connectivity. You need to think about what's going to be passed across your bandwidth. You need to think about what else is sharing that bandwidth. Typically, we see one of the flavors of interconnect. So this helps. This is important because it helps you get over the variances of transferring stuff across the internet. Okay, you've got more control over the hops. So once you've decided on how you're going to connect, you then need to think about how you do the transfer. Initially, you tend to seed your environment, so you have a large amount of data. So use something like the Google Transfer Appliance. And then once you've got that seeded and you've got your warm standby or whatever on GCP, you can then use maybe something like GSUtil or the Google Transfer Service to move over incremental updates. So there's typically data involved when you do DR. So I tend to put it into two lots, what I call data backups and database backups. Data backups are just essentially a discrete amount of data copied from one place to another place. Okay, so typically cloud storage. Whereas database backups tend to be more complicated because you're copying over the backup of your database using the system that your database engine uses to create the backup, and also the transaction log files, particularly for relational databases. Plus, you've got to make sure that in GCP, you've got the ability to run the correct version of the database server so that you can actually restore the backups and the transaction log file. So it tends to be more complicated. And the key thing there is the recovery point objective. So you've got to make sure that you're also thinking about getting your transaction log files over a good cadence. A typical pattern for DR is a tiered storage pattern. So traditionally, this means tearing data from local fast disks to slower, cheaper disks as you move along. In GCP, it's slightly different. So you have the fast, persistent disks being the faster local disks, and then you tear it to cloud storage. So the performance is the same for both of those, and you tear, but it's as you don't need access to the data as quickly, it becomes cheaper to store on cold line or nearline. Okay? And just to show you that the patterns are the same, whether you do it on-prem or not, here we have a tiered storage pattern whereby you've got cloud interconnect connecting to your on-prem to GCP. You've got your on-premises storage array, and you're tearing data off to a regional bucket and then to nearline or a cold line bucket. You could actually decide that you want to change the class of the object when it gets to the regional bucket. What I find is that most people tend to actually just want another bucket to do the tearing because logically it's easier to see. Okay, sorry. So GCP has a number of managed databases, and they're designed for scale and volume. So they're designed for managing petabytes of database. So, laws of physics, doing backup and restores of huge amounts of data is just going to take an awful long time. So you need to think about how you design those databases. Maybe have tables that are designed so that you've got, dates. So if there's a corruption for a particular date, you only have to worry about that slither of your database. These systems tend to be replicated underneath anyway, but we do understand people want a better level of comfort. You could export things to cloud storage, or you could keep the raw files. Maybe you only need that day's bit of data to actually get up and running. So you just need to think it through. I'd also like to call out here Cloud Composer. This is our managed Apache Airflow. Using a directed acrylic graph, it allows you to design a flow for moving data around. So you can use it, and it had operators, which are plugins, for things like BigQuery and cloud storage. So you can use that to move data around from cloud BigQuery and cloud storage to get a backup system that way. OK, fun bit. We'll look at some architectures. Let's start by looking at production on GCP. HA first. You need to think about high availability when you're designing your application on GCP, because they've got these features built in, so zones and regions. So we've talked about most of these briefly, so I can whiz on. The security controls you don't need to worry so much about because you're in GCP anyway. So you would have defined your security controls, and they'll be easy to apply to your new environment. Here's an interesting DR scenario. You're running your web servers out of GCE, and if for some reason you've also got a static website on cloud storage that's sitting there looking interesting. So say there's a problem with serving out of your web service out of GCE, then what you can do is you can flip Cloud DNS to point to your static website. If your web servers haven't actually got that many moving parts, bit of JavaScript, static website is actually a really cost-effective way of getting something up and running. You could, of course, do a HA web serving application. Okay, so here we're using a regional managed instance group, so there's instances across all the zones in the region. If one of the zones has a problem, then it will start up an instance, so you can still have your load in one of the other zones. At the back end, we're using Cloud SQL, and it's doing semi-asynchronous replication to the replica in the other zone. When there's a problem, it will automatically fail over. Yes, your current connections will be lost, but they will be reconnected. But crucially, you're still serving data. I talked about the single IP address. This is where this example comes in. So you have a single running server at any one point, typically for a database, maybe for an application middleware type service. In the event of a problem, you've taken snapshots of this persistent disk. In the event of a problem, the snapshot creates a disk in another zone. I could have used regional persistent disk here as well. So that's another alternative. The reason you use snapshots here is because standard persistent disks are zonal. You'd also take, don't get me wrong, you would take snapshots of the regional as well, but the mechanism works different. I mentioned you could see Deployment Manager on the list of the building blocks here. Deployment Manager is here used to bootstrap the managed instance group and also to inject, to start up a HTTP server where you are echoing your custom metrics to that stack driver can receive, and then that actually kind of helps you, which actually allows it to realize when there's a problem with the actual application. Because sometimes the instance might be all right, but it's the application you're worried about. The productions on premises. This is all about connectivity, really. Cloud storage and partners. We've got some fantastic partners. You've seen one. We've got another one coming up later to do another demo because I like people to see demos. And then there's the security considerations. This is something that you need to really think through. You need to think about mapping your security controls and the permissions your users have to GCP. So I spoke about that in the planning stage. A compute engine and Kubernetes engines tends to be the compute that I see a lot in this environment. Here we have a warm standby setup. You're running production out of your data center. You'll notice that we're actually replicating data to a database on GCP. That instance is quite small. It's just sized to run the minimal to take the replicated data. I've chosen, so when in the event of a problem, Cloud DNS points to web servers that have been created by snapshots. I chose snapshots here because this is a fast-moving org in this example, and they're constantly changing the web service, so snapshots were the quickest way. You could also have chosen custom images as a way to do that, okay? And then obviously you can also, to take the database, to take production workloads, you can enlarge it so it can cope with the production workloads. And you can have hot HA across GCP and on-premises. If you do this, make sure you've got something that has a weighted, is able to work with weighted records, so you can distribute traffic across premises. All right. And at this point, I would like to introduce Brylan from Actifio, and let's hope the demo gods are still with us, who will also talk to you about how they can help you with your DR environment. Thank you.
Thank you very much. So I'll start off with just a few brief slides, and then we'll jump right into the demo in the interest of time. I'm from Actifio. Actifio is a company, a software company started in 2009 that was created to really modernize the way customers manage data. And what our software delivers is what our customers refer to as data as a service, allowing customers to access the data they need wherever they need it for multiple different use cases, data protection, disaster recovery certainly, but even things like test and development, DevOps, and analytics use cases. Today we're going to focus on disaster recovery in GCP. So let's jump right into it. The way Actifio works, it's a little bit different than the previous solution that you saw. We manage discrete application-consistent images of different applications in the environment. It might be a virtual machine, it might be an Oracle database on a physical server, it might be a SQL server or something like that. But all the different workloads that we manage, including things like SAP HANA, everything we do is incremental forever updates, moving only the changes as efficiently as you possibly can, using incremental changes and compression to very efficiently move data from wherever it is, on-prem or maybe another cloud, into its destination, like GCP. So everything we do is discrete images, app consistent, which is important for us, but it's not real-time or CDP. It's going to be job-based, and RPOs along the lines of 15 minutes is what we advertise. And Actifio software runs natively in GCP. It runs on premises. It runs anywhere the data is, and takes this application-consistent data and provides access to it wherever you'd like to use it. And so for the DR scenario into Google Cloud Platform, we really got two different ways we can do it. Actifio is all about letting customers manage their data independent of the infrastructure involved, whether that's on-prem or whether that's in the cloud. And so we've got two ways to do this. The first way is our higher performance method, and that is the customer is going to deploy Actifio. This is a DR to the cloud scenario, so the workload's on-prem at the customer data center, and we're going to do DR to GCP. So the customer would deploy an Actifio virtual appliance in a hypervisor of their choice on-prem. We're going to capture those changes incrementally forever. We're going to provide access to the data locally for local recoveries. As Grace mentioned, that's certainly important. You want to avoid the DR event as long as you can. If you can access it locally, great. But obviously to get it into GCP, we're going to replicate that compressed, encrypted, incrementally forever. So it's very, very efficient on the WAN. And in GCP, we're going to send that to an instance of Actifio software. In this case, our virtual appliance, which we call Sky, is going to be running in GCP. It's going to receive the data, and we're going to store those application-consistent images in the infrastructure of your choice. For the highest performance, it would be a Google persistent disk. You can use a spinning disk. You can use flash storage or SSD, if you like. And then from there, we're going to provision the data into existing virtual machines or even create a new virtual machine, which is what we'll show you in the demonstration. That's the higher performance option, which comes with a little bit additional infrastructure cost, right, for that performance, for the Google persistent disk that goes with it. and the compute, running Actifio software in the cloud. We have another interesting architecture here as well, where we can do the same thing without running any compute in the cloud. We're going to take the data from our software on-prem and just stick it directly into object storage. Object storage is really, really cool, not only for disaster recovery, but also for data protection, which is another use case that Actifio solves for, where we can keep the most recent copy in object storage. We can keep the copy from 30 years ago if you want to, because it's very, very cost effective just by simply incrementally updating those blocks. And you don't have to run any compute in GCP, including the Actifio software, until the time of a disaster, where you would spin up Actifio software, point it at the object bucket, right at the near line or cold line, and we'd be off and running with recoveries. So it provides a slightly slower, lower performance level, but still gives you that ability to do recoveries for DR as well as backup scenarios in the cloud, which is really cool. So at this point, let's jump to the demonstration. If you could, please switch over to the laptop. Perfect. So this is our Actifio user interface, and I'm trying to make up a little bit of time here, so I'll go relatively quickly. This interface shows the data that we're managing on-prem and in the cloud. It's based on SLAs, or service level agreements. Here you can see we're capturing the data every 8 hours. In this case, we're keeping 3 days of history local for local recoveries, and then we're streaming it up into the cloud. Actually, 2 different ways. We're keeping the most recent version on higher performance disk, and in this case, we're also doing daily versions for 60 days of history in GCP on nearline or cold line object storage as well. So we've already done that through the magic of television here. I'm jumping over to this environment, and I'm going to show you a virtual machine. This is a VMware virtual machine on-prem called Demo SQL 1. And I'm going to click on Access My Data here. There's all kinds of things you can do, but keeping it short and sweet here. I'm going to show you the recovery points that we have in the cloud. We'll take the most recent one, and I could present that data into a running VM. If I already have a VM running in GCP, I could simply present the data into it in a couple of minutes, which would be that screen, which I didn't mean to click. What I wanted to do was a different screen, so apologies here. Go back to Access. And what I'm going to do is recover the system. We don't have the VM. Let's take this VMware VM from on-prem that we've replicated into GCP, and let's make it into a GCP VM. So I'm going to come in here. I'm going to call this Demo SQL 1 in GCP. I've got some options here, including providing authentication, right, with a JSON file that's got the credentials for this particular area and region and in zone and all that good stuff in GCP. And I'm just going to click the button. And what this is going to do is essentially start a job that's going to take the data we already have, orchestrate with the APIs of GCP, and create a virtual machine from that data that was a VMware VM on-prem just a few moments ago. So I've got a little job monitor here, which is right on this window, and I've got a compute engine right here. And so what I'm going to do is, looking at GCP, I'm going to filter this for demo. And this will just take a couple of minutes. We basically provision the virtual machine, copy the system state information onto it, right? All the Windows, registry information and boot information. Essentially taking a vanilla Windows image in GCP and turning it into your image from the on-prem virtual machine. So this will just take a few moments to see our new virtual machine show up. So I will impatiently click the refresh button, as you do in a live demonstration. There it is. There we go. So there's Demo SQL 1 powering on, and the process continues from there. In just a few moments, we'd have a virtual machine running in GCP that was on-prem in a VMware hypervisor previously. If you want some more information, we're at the booth downstairs on the first floor of this building, so I will hand it back to Grace, and thank you very much.
Thank you. Okay. So, in the interest of time, I'll whiz on. So, thank you very much again. Production on another cloud. This is all about common tooling. So Kubernetes, and I'm not going to add to that. There's some great talks about Kubernetes that can do more justice than I can, but you can run it on-prem, on another cloud, and on GCP, various managed services. Cloud storage and Amazon S3 compatibility. You can use Boto, which is a Python tooling that allows you to write objects to both cloud storage and S3 with the same tooling. Again, there's connectivity, and you need to be able to map the security controls from one to the other. So just to wrap up, a few tips for when you're doing for DR. Identify your RTO values per system and within the system. Identify your dependencies. They may not always be obvious. Understand the repeatable architectural patterns. So like when I talked about tiered storage, think about how you can apply them. I find it helps to list out the security considerations, permissions, as well as the controls you need to apply. And define how you will deploy your deploy to your DR environment on GCP, i.e., remember, if your production environment isn't available, how are you going to get updates to your DR environment that may be running production for longer than you expect? And test your plans regularly. You can now. You only pay for what you use. You can use Deployment Manager to treat your infrastructure as code. So do that. And GCP for DR. Why? Total cost of ownership. No having to invest up front in mostly idle infrastructure. It's easy to carry out fire drills. Test, test, test. I know I keep saying it, but really do it. And no matter where your production is held, the same approaches apply. Obviously, there are differences, but it's the same approaches. And once you start using GCP for DR, it does actually make the migration path easy. So thank you for listening.